Hi, and welcome to this module. I'm Daniela Peguero, a researcher at SUNDEC. Let's talk about something that's heating up our planet. Municipal solid waste is the fourth largest source of greenhouse gas emissions. These emissions drive global warming and ultimately cause climate change. So how are waste and climate change connected? In this video, you will recognize the major way in which waste contributes to climate change, explore key waste management strategies in reducing greenhouse gas emissions, and understand how climate change affects waste management systems. Waste, including wastewater, accounts for 3 to 5% of global greenhouse gas emissions. However, many experts believe this is a big underestimate. So, which gases and emissions contribute to global warming? The most well-known greenhouse gas is carbon dioxide. However, others have a much higher global warming potential, GWP. The GWP is a measure of how much heat a gas traps over a certain time and is expressed in CO2 equivalents, using most often a 100-year period. Methane, CH4, is considered 28 times more potent than CO2 over a 100-year period. Nitrous oxide, N2O, is considered 298 times more potent over a 100-year period. And black carbon, which is a short-lived climate pollutant, may be 460 to 1,500 times more potent than CO2 over a 100-year period. The variation in this number shows that effects are still not well understood, although the impact is high. Together, these emissions accelerate global warming and climate change. These gases are released in several ways throughout the waste life cycle. Landfills and dump sites emit methane as organic waste left in uncontrolled landfills, open dumps, and wastewater decomposes without oxygen, which accounts for around 20% of human-caused methane emissions. Nitrous oxide can also be released from nitrogen-rich waste like food waste. Open burning, especially in areas without formal waste systems, accounts for about 40% of global waste disposal and releases black carbon and other toxic pollutants. Emissions also come from transporting and processing waste. Fossil fuels burned during collection and transport emit CO2 and black carbon, especially when using older vehicles and lower quality fuels. Some recycling processes are energy intensive but emit fewer emissions than producing materials from scratch. We can reduce these emissions by 15 to 25%. So the solution? Waste reduction by, for example, minimizing single-use plastics. Less waste means less emissions. Recycling and resource recovery. Recycling materials such as paper, glass, metals, plastics, textiles, and electronics prevents emissions from raw material extraction and production. For example, recycling aluminum saves up to 95 kilograms of CO2 per ton of material recycled compared to dumping. Organic waste diversion. Diverting organic waste from landfills can cut emissions. Landfill gas recovery. Capturing methane from landfills and converting it into energy can reduce emissions into the atmosphere while generating power. Phasing out open burning. Replacing this practice with sustainable alternatives can significantly cut emissions and toxic exposure. Beyond technology, policy and public action matter too. Governments and organizations can enforce stricter landfill regulations, support waste reduction programs, and launch public awareness campaigns. These strategies can be a part of a country's nationally appropriate mitigation actions, NAMAs, climate actions adopted by developing countries as policies or actions to reduce greenhouse gas emissions. Let's walk through an example of potential emission reductions from organic waste diversion using black soldier fly technology. Every ton of food waste sent to a landfill produces 0.93 tons of CO2 equivalents. If we divert 10 tons of organic food waste per day to a BSF facility, and the average emissions is 0.175 tons of CO2 equivalent per ton of food waste treated, we would emit 1.75 tons of CO2 equivalents per day. But if the same 10 tons of waste went directly to a landfill or open dumping, we would emit 9.3 tons of CO2 equivalents per day. So by diverting 10 tons of organic food waste per day to BSF, you're saving 9.3 tons minus 1.75 tons, equaling 7.55 tons of CO2 equivalents per day. Now that we understand how waste contributes to climate change, let's look at the other side of the coin. How climate change affects waste management systems. Well, excessive rainfall can flood roads, disrupting waste transport and collection. With poor infrastructure maintenance, this can trigger landslides at landfills or dump sites. This was the case when heavy rainfall triggered a devastating landslide at the Chitezi dump site in Kampala, Uganda, claiming the lives of at least 35 people, highlighting how excess moisture and weak waste management infrastructure makes dump sites highly vulnerable. Meanwhile, rising temperatures accelerates the breakdown of organic waste, increasing pests and pathogens, raising health risks for waste workers and nearby communities. Increased winds and dry conditions scatter lightweight waste and increase the risk of long-burning fires at dump sites, releasing harmful gases. Rising sea levels also threaten coastal waste facilities with flooding and erosion, increasing the risk of marine pollution. Therefore, conducting site-specific risk assessments, better maintenance, infrastructure upgrades, and mitigation strategies are needed. To summarize, waste management is a significant source of emissions, likely higher than the reported 3 to 5% contributing to global warming and climate change. Waste management strategies can reduce emissions by 15 to 25%. Climate change also affects waste management systems. Want to learn more? Explore further recommended resources.